Hi there, and welcome to another video of CodeRash with Gaurav. In today's video, we are going to look at what is a closure in JavaScript and what are its practical uses. You would have heard about closures and you might have read a lot of definitions around it, and mostly people start with examples. We will first look at what is a scope, what is a lexical scope, and what is a nested scope, and how lexical scope plays a part in closure. And we'll look at what closure is first, and then we'll look at example. And as a bonus in this video, you'll also see a very popular JavaScript interview question, which is about function curry. So stay tuned and let's get started. Before we jump into closures, let us first understand what is a scope and what is a lexical scope in JavaScript. Let us first talk about what is a scope. Scope defines a boundary in which your variable is available. Now, whenever you define a variable in JavaScript, it has to be associated with a scope. And within that scope, that variable will be available. Outside of that scope, it won't be. Now, how do we define a scope in JavaScript? We just have to define it using curly brace. Now, this is a proper and valid JavaScript syntax. I should be able to run this code without any error. It doesn't throw any error, and this is a valid JavaScript syntax. So, this curly braces, these define a scope. Now, if I declare a variable here, let a equals to 10, and if I console log this variable, I should see 10, and this also is a valid JavaScript syntax. Now, scope can be either global, which is the part of global execution context, or it can be a local scope that you are creating here. Like we just created a curly brace scope and we declared a variable. Now, if we try to access this variable outside of this particular scope, we shouldn't be able to. And let us verify that fact. We are getting an error saying A is not defined when we are trying to log it outside of the scope. Now this makes us understand that the scope defines a boundary in which a declared variable is available. Now that we know what is a scope, let us see if we can have nested scopes, and we'll also see what is a lexical scope. Let us first get rid of this log and let's see if we can have some nesting within the scopes. So I can declare another scope here, and I can have a variable created here. Let's say let b equals 20, and let us just console this, console log of b. Now if we run this, we should be able to see the respective logs, which is 10 coming from here and 20 coming from here. Now this scope, the inner scope, is within this parent scope, and you can have any level of nestings within these scopes. Now let us try to log something coming from outer scope here. Let's have console.log, and let us try to log a, and let us see if a is accessible within this particular scope. So we get this 10 and 20 as a log. So now we know that the variables created within the outer scope are available within this nested scope. So any inner scope can access the variables created within the outer scope. Now this particular inner scope will have two kinds of scopes. One is its own scope and one coming from its parent, and this parent scope is called as lexical scope. Now because of this fact that any inner scope can access its parent scope, and because of the fact that it is lexical scope, closures work. Now let us see what is a closure and how does it work because of the lexical scoping. So far we saw that when you create a scope, and what is a scope? A scope creates a boundary for a variable to exist. Now when we declare let a equals to 10 here, it had to be available within this entire scope, and because we are trying to access that within the inner scope, there is no magic of closures yet. A had to be available. But let us see an example where the outer scope has finished execution, but still we can access the outer scope in the inner scope. Don't get daunted by what I just said. Let us try it out as an example. So let us have this guy as a function. Let's call it outer function. Now whenever we create a function, the function itself creates its own scope, and within this scope, whatever variables we are creating, they won't be available outside. If we run this program right now, we should see the same thing, same result, no changes over there. But this outer function could return this inner scope as another function. Let us try to do that. Return this guy as a function Let's call it inner function and try to do the same thing. Now if I say outer function, if I call outer function, I should get only 10 because I'm not calling the inner function yet. Now this guy returns me some handle to the inner function, because this guy returns me function. The outer function, when I call it, gives me the handle to the inner function. So let me have that declared here. Let's say inner function equals to, I'm copying that reference in the inner function, and let us call this inner function from here. We see the same result, and there is one trick to understand here, and which is very interesting, and this is only possible in JavaScript. Like other languages would have had problem with such a syntax. Now what happened here is, when I executed line number 15, outer function got called, and this function would have been called, the variables would have been declared, and I returned a value from this. So the outer function execution is complete and I got the return value. So A should have got destroyed. Now when I'm calling inner function, it has a reference to A, and when I call inner function, I am still able to print the value of A. That means the lexical scope came into the inner function, which did not get destroyed even if the outer function has finished its execution. This exact thing is called as closure, and closure works because of the lexical scope. Because of the lexical scope, A was available. The variables created within the outer scope were available in the inner scope, and because of closure, even if the outer function, the outer scope has finished execution, you can still access the outer scope within the inner scope. And this fact is basically called as closure. If you read online, you might have seen a lot of explanations of closure, where examples of closures are shown, but there is no clear definition of closure. Now closure, let us understand what it is. The inner function here, that function is a closure. And if we want to break it down into sentence, a function which has access to its lexical scope even after the lexical scope has finished execution, that kind of function is called as closure. So in this case, our inner function had access to the variables and the scope created outside it, that means its own lexical scope, even after the outer scope has finished execution. So in line number 15, the outer function has finished execution when you reach line number 16. But still, inner function has access to the variables or the scope coming from its lexical scope, basically its outer function. And because of this, the inner function is called as closure. Let us try to understand this better by running this in the browser. We will try to see, when we are reaching the inner function, what all kinds of scopes are available. So let me put a breakpoint here and let me refresh this. So I'm stopping at the invocation of inner function, and I'm stopping at line number 10 where I'm trying to print console log A. Now at this point, if you look at the scope tab within the developer tools, let us see what all kinds of scopes are available. There is a local scope available which has the value of B as 20. Fair enough. There is a closure that is coming into this scope coming from outer function, and this guy has A as 10, and because of this, A is accessible even after the outer function has finished execution, and that is injected into inner function as a closure, and because of this, inner function becomes a closure. Now that we know what is a closure, let us look at some practical examples of closure. One common example is probably whenever you do a fetch call, you will do something like this. You will have a function which does the fetch. To that function, you will pass some parameters, and then you will bind some callback to the actual fetch call. And you might want to use those parameters within the callback function. Now this callback function forms a closure here where the scope variables like parameter here, like the params here coming from the outer scope are still available, and when the outer scope has finished execution. So that because you are able to use params within this callback function, this forms a closure here. This inner anonymous callback function forms a closure here. Another very popular example of closures is function currying. And this is a very important and most popular interview question. Like, you would be asked to write a function which can infinitely take parameters of numbers and it will keep adding to the sum. And if you don't pass anything, that means you are expecting the sum so far. So in this case, I should be able to call a function which is called as sum. I should be able to call this function n number of times with the parameters which are numbers, and it should keep adding to the sum. Like till this point, my sum should be 1 plus 2, which is 3. Till this point, my sum should be 1 plus 2 plus 3, which is 6. And if I don't call this with a parameter, that means I am expecting the result back, and that should give me 6. How do we implement this? We implement this using function currying, and function currying is nothing but an implementation of closure. Now let us look at the example and the implementation here. How are we implementing sum function here? So sum function has to return a function. You cannot have this as a valid syntax unless sum returns a function. So this part would have returned a function, and that function you are invoking again with another parameter. So sum function has to return another function, and we'll see what that function does. So what we are doing over here is function sum. This guy maintains outer variable scope which is called as sum so far. Now this sum so far has to be made available within this inner sum. We are returning a method which is called as inner sum here. So inner sum accepts b, which is the second parameter. If I call this further, the inner function also should expect some parameter which is going to be b here. And if I'm checking here, if b is not undefined, that means I have a valid number to be added to the sum so far. I just keep adding to the sum so far and return inner sum itself. That means I want to keep going ahead with the same functionality. I return the function itself so that somebody can call the return again, and it can call again with a different value. If there is no valid input provided, if it is undefined, we are going to return the sum so far. So if you see here, till this point we would have got this function inner sum, and whenever we call it without parameters, this condition would become false and we'll go into else, and we'll return the sum so far. Now in this case, the sum so far, if you look at this particular variable, this variable lies outside of this inner sum scope. That means the inner sum forms a closure, and while the sum has finished its own execution, the inner sum function can still access sum so far, which is coming from its lexical scope, and keep updating its value also. Not just access that, it can also update its value, and inner sum forms a closure here. Now let us run this and look at this in more detail in the browser. Now let us run this in the browser and see, putting the breakpoints, what all do we have in the scopes. We are calling sum with 1, 2 and 3, and at the last we don't call it, we call it without any parameter. That means we are expecting the value out of it. Let me refresh this and run again. So when we are calling the inner function, that means sum1 would have been called, and now we are calling sum with this return function with 2. That means b is 2 here. In this particular case, I have sum so far, which was the first input parameter, which was 1. So a had 1, sum so far had 1, now I'm getting 2, and b, which is not undefined, which is a valid input, I am adding sum so far. So at this point, let us see what are the scope variables. Within this local scope, you have b coming in as 2, which is the input parameter of this function, and there is a closure which is incoming from the sum function, which has sum so far, which is 1, and because of this, sum so far is injected into the inner sum as a closure coming in from sum, and you can not only access that value, you can also update that value. So if we continue ahead, we should see input as 3, the next input as 3, the sum so far is 3, we should be able to add 3 plus 3 and 6, and the next input is going to be blank, b is going to be undefined, and at this point we are going to return the sum so far, which is 6. This is how the function currying works and the closure works. If you enjoyed this video, learned something new today, do leave a like on this video, share this video with your friends, and subscribe to this channel. Tell me in the comments what all topics I can cover next, and I'll see you in the next one. Till then, take care of yourselves and bye-bye.